FAIMS stands for High Field Asymmetric Waveform Ion Mobility Spectrometry, and it really is an ion filter. It prevents certain ions, the unwanted ions, from going into the mass spec, but it lets the ions that you want into the mass spec. As you can see here, this first chromatogram shows a lot of co-eluting interferences and chemical background, in addition to the analyte of interest. When we use FAIMS, we only let the analyte of interest into the mass spec, and so those other interferences have been removed. Bioanalytical chemists are often using plasma, serum, or urine, and they will often use tissue matrices as well. And really, the dirtier the matrix, the better, because even if these interferences have the same mass transitions, they're going to have different FAIMS properties, so that FAIMS can eliminate those interferences and let only the analyte of interest into the mass spec.
A common problem we have with biological assays is limited detection, not due to a lack of analyte ion signal, but from too much chemical noise on the SRM channel. So if we could transfer only the ion of interest into the mass spectrometer and filter out the chemical noise, mass spectral peak detection will be simplified even in the dirtiest of biological matrices. And with FAIMS we can do that. The ions are produced in either the heated electrospray source or the atmospheric pressure chemical ionization source. And we use these heated sources because it's very necessary for us to produce dry ions for the FAIMS experiment. These ions enter the annular region between two concentric cylindrical FAIMS electrodes and are transported towards the mass spectrometer entrance via a flow of clean, dry gas. We use a mixture of nitrogen and helium. Once inside the electrodes, on this center electrode we apply an asymmetric waveform, and this asymmetric waveform produces alternating high and low electric fields. The high field is applied for one time unit, followed by an opposite polarity low field component applied for twice as long. Since the magnitude of an ion's mobility is different at these two electric field strengths, the ion is slightly displaced away from the center of the FAIMS device. Over many cycles of the waveform, ions travel towards one or the other electrode. A low DC voltage compensates for this migration by drawing the ion of interest back to the center of the device. This results in a select ion subset being transmitted into the mass spectrometer. Since only the ion of interest is passed into the mass spectrometer, it leaves the mass spectrometer's components cleaner.
The goal is to get the greatest selectivity possible, and that's what FAIMS offers. So when you combine it with heated electrospray and HSRM, you get the greatest selectivity in your bioanalytical assays.